All right, today we're going to talk about function notation, and we're going to put some domain and range in there, and we're also going to talk about, is it a function, okay? All right, so a few definitions. What is the definition of a function? The definition of a function is a relationship, okay, where each x value has one y value, okay, where each x value has one y value. That's very important, okay? Because that tells you if it's a function, okay? Each x value can only have one y value. Think of it as a function's very kind of stingy. They, like the x values, they only want the y value to have one. Like it's one per thing, okay? You're being stingy, all right? So to be a function, you got to be stingy, and you only want one of each, okay? So the x value doesn't want to share its y value with anybody else, okay? The definition of domain, simplified definition, is going to be the x values of a function, okay? So the x values of a function, okay? All right, the definition of range is going to be the y values of the functions. All right, so when I ask you for the domain, I'm literally just asking you what are the x values on this function. And the range is what are the y values on this function, okay? All right, let me thicken this pen a little bit. There we go. So how can we tell if the graph is a function? Well, by looking at the graph, you can either look and see if each x value only has one y value, or you can do what we call the vertical line test. Okay, so how can we tell if a graph is a function is if it passes the vertical line test. All right, it's just where you draw a vertical line and it can only hit the graph once, which is what this says. So the next one says, how can we tell if a table of values, so table of values where you have your x and y, represents a function? That goes back to the definition of a function. So that's why it's really important you know your definitions, okay? So how do we tell if a table of values is a function? By each x value has exactly one y value. That is so important. Exactly one. Okay, one y value, all right? Okay, so I want you to tell me whether the following are functions or not. Okay, so when looking at a graph, we do the vertical line test. Now, vertical line test, vertical means up and down, okay? So when I do the vertical line, it can only touch the graph once, okay? Okay, you can draw as many vertical lines, but each vertical line can only touch it once. So I'm going to draw, let me get a lighter color. Let's get a yellow. All right, so I'm going to draw a vertical line. It hits it twice. Do it again. Hits it twice again. So this is not a function, okay? And explain why. It fails the vertical line test, okay? All right, next one. Do another vertical line. Bam. Well, it crosses it twice. Bam again, crosses it twice again. So again, this is not a function because it fails the vertical line test, okay? All right, again, let's do it here. Bam, hits it once, we're good. Bam, hits it once again. So this is a function, so yes, it is a function. Okay, because it passes the vertical line test. Okay, all right, now let's look at some table of values. So the table of values, it stated that there can only be one y value. So that means, so basically for a table of values, your y values, let's make my pens thicker. All right, so when looking at a table of values, you're looking at your x values, okay? Your x values cannot repeat. Okay, so your x values cannot repeat when you're looking at this. So we're going to look at the x values. That's right here. Okay. Now, I know you see this f of x. That is function notation. Okay, f of x is function notation, and it just means y. Okay, so f of x is y. Okay. All right. So we're looking for x values. Do they repeat? Yes. I've got 2 5s there. So this is not a function. Okay, because 5 has 2 different y values, because my x, or you could just say your x values repeat. Okay, see how this one has a -1 and that has a 1? They repeat. So it is not a function. Okay, so look at E. E, my x values do not repeat, so this is yes, it is a function. Okay, because each x value has a different y value. Okay, your x values do not repeat. Looking at F, do your x values repeat? Yes, I have 2 zeros with 2 different y values, so that means this is not a function. Okay, because my x values repeat. All right. So now we're going to look at a relation. This is called a relation. It's just where you have ordered pairs listed. Okay, it's just another way to write your input and output values. Okay, so G, you're still looking for the same thing. You're looking that your x values do not repeat. Okay, anytime you're given numbers, you do not want your x values to repeat. Okay, so x values cannot repeat. Anytime you're looking at ordered pairs, if it's in a list form or if it's in a table of values form, your x values cannot repeat. So if you look, I have 4 different x values, so yes, this is a function. Okay? Now, when you're looking at, this is called a map, okay? When you're looking at something that's a map, you're looking to make sure that you don't have 2 arrows coming out of it. So basically, when you have these 2 arrows coming out of here, it means this 6 is listed twice. So let me put this map in a coordinate form. So this is saying my input's 5, which that's your x value, and your output's your y. So this is saying this coordinate is -15. This is saying that there are 2 coordinates that come out of this, 6 and 3, and 6 and -2. And the last one is just 1. This is -6, 12. Well, if we go back to x values cannot repeat, my 6's repeat here. So this is not a function, okay, because my x values repeat. So when you have a map, if there are 2 arrows coming out of it, that means your x value repeats, okay? All right, so now let's go to interval notation, because that is how you're going to be writing your domain and range. In Math 3, we use interval notation, okay, not inequality notation. And that's what you're used to, is this is inequality notation, okay? We want to switch to interval notation, okay? A lot of words. All right, so this one. This is saying my x's are greater than 4, okay? So what I tell them is to look at this arrow. Where is this arrow pointing? It's pointing to the right. Well, if you go to the right, that's positive numbers, right? And if you keep going on and 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 on to the right, where do we say you're approaching? If you keep going on and on and on, infinity. So this is saying that my x's are going from 4 to infinity. So my x's are going from 4 to infinity, okay? Now, infinity always has parentheses, okay? Now, I want to talk about this less than, and this greater than, and then I want to talk about this less than or equal to. If you have a less than or a greater than, that is parentheses, okay? If you have a less than or equal to or a greater than or equal to, that is brackets, okay? So you see how this is just a less than? That means 4 is going to get a parentheses, okay? All right, B. This arrow is pointing to the left. So it's saying my x's are less than -2. To the left on the number line, that is going to be negative infinity. I mean negatives, right? Well, spoiler alert. So if I keep going to the left and keep going to the left and keep going to the left, I'm eventually going to approach negative infinity. So I have negative infinity, and I'm stopping at negative 2. Infinity is always parentheses. This is less than or equal to, which gives me a bracket. Okay? All right, now looking at this graph right here, an open dot, so an open dot is going to be parentheses. A closed dot is going to be brackets. Okay? So this open dot, see how it's shaded over here to the left? And then see how it shades that arrow? Well, again, who's that arrow pointing to on the left? Negative infinity. So it's saying my x's are coming from negative infinity, and they're stopping at 7. It's an open dot, so it's parentheses. Then we're going to use what we call a union. Okay, anytime you have a gap, see there's this huge gap right here? Anytime you have a gap, we use union. Okay, let's put an arrow there. Then it picks up at 11, and then it shades to the right, and it shades the arrow. Well, that arrow is pointing to who on the right? Positive infinity. That's a parentheses because it's infinity. That's a closed dot, so it's a bracket. And that's your answer. Okay? All right, let's go to the next one. So this one I'm going to go through. We're not going to really worry about set notation. Okay? We're not going to do set notation in this class. Okay? So we're going to mark that out, which is all good. Interval notation though. Okay? So how about, instead of this, let me write it in inequality notation. So, which it basically kind of is. So I'm just going to mark that out and mark that out. And that gives me my interval notation. We're going to say x is greater than 7. Greater than or equal to 7. There we go. Okay. So I want to go from interval notation. This is inequality notation is what this is. That says inequality notation. All right, so interval notation. You see how it says my x's are between negative 3 and 8? So that means all my x's are between negative 3 and 8. So that means my x's are between negative 3, comma, 8. It can't equal negative 3, so we put a parentheses. It can equal 8, so we put a bracket. Okay? I'm not going to worry about graphing this one because we're focusing on interval notation. Okay? All right. So let's skip this one too. So I want to put this graph into interval notation. Well, again, it's shading to the left. And who does the left point to? Negative infinity. And it stops at 3. Infinity is always parentheses. That's an open dot, so 3 is also a parentheses. Okay? This inequality, it says my x's are greater than or equal to 7. See how that arrow is pointing to the right? Well, to the right is going to be positive infinity. So it's saying I'm going from 7 to positive infinity. I'm going from 7 to positive infinity. Infinity is a parentheses. That can equal 7, so it's a bracket. Okay? All right. Now, we're going to do, is it a function? And write the domain and range. So you've seen domain and range. Domain and range is how wide is the graph. Range is how tall is the graph. Okay? So is it a function? Does it pass the vertical line test? So we're going to do this one. Okay? So, yep, it passes vertical line test. So yes, it is a function. The domain. Okay? So domain. How far left is it going? Well, it's going down and to the left. And it's going to keep going to the left. Well, who keeps going to the left? Negative infinity. Okay? And then it's going to go up and to the left, into the right, and it's going to keep going to the right. And if it keeps going to the right, that's positive infinity. Okay? The range is how low does it go to how high does it go? Well, this graph is going to keep going low, right? And if it keeps going low, it's going to be negative infinity. And this one's going to keep getting higher and higher. which is positive infinity. And that's your answer, okay? I don't know. Don't doubt me. All right, so now let's do the next one. Let's switch up. Let's go to some green. So is it a function? Does it pass the vertical line test? Yes, it does. So this is yes, this is a function, okay? The domain, how wide is this graph? Well, this graph's going to keep going, isn't it? Right? It's going to keep going. See, that arrow means it's going to keep going to the left, which is negative infinity. This one's going to keep going to the right, which is positive infinity. Okay? The range is how high is this graph to how low is this graph. Well, if you look, the graph never goes above right here, does it? And the graph never goes below right here, does it? So this point right here is -2. And it's a closed dot. And this graph right here is +2. So it goes as low as -2 and as high as +2. Okay? All right, let's do another one. Here we go. Is it going to change? There we go. Okay. All right, so C. All right. So is it a function? So we do our vertical line test, and it passes. So yes, it's a function. Okay, let's do all of them. Vertical line, yes, that's a function. Vertical line, it passes here, but does it pass there? No, so this is not a function. Okay, has to pass everywhere you draw a vertical line. That's why I draw multiple of them. Okay, and if it fails at one vertical line, then it's not a function. Okay, all right, so let's trace our vertical lines. All right, the domain. Let's do the domain for all of these. So your domain is how wide your function is. Okay, so look, this is going at a slant. So see how it's getting wider and wider, right? So it's getting wider and wider. So it's going to keep going to the left, which is negative infinity, and it's going to keep going to the right, which is positive infinity. So my domain here is negative infinity to positive infinity. Okay? D, how far left is it going? Well, that arrow says it's going to keep going left, which is negative infinity. And this arrow says it's going to keep going right, which is positive infinity. Okay? Now, the domain here, that's not an arrow, is it? It's not. That is a closed dot. So that means this graph stops right there. So it stops at -5 with a closed dot. Look right here. There's no arrow. So it stops at 1, which is a closed dot. Okay, so not all of them are negative infinity to positive infinity. If it doesn't have arrows, it's going to stop at a point. Okay? All right, now let's do the range. Okay, how low does this function go? Well, both arrows are pointing down, and down is negative infinity. But my negatives always run into my infinity. But how high does this graph go? There's no arrows up here. It actually stops right there, which is 1, 2, 3, 4. So it's going to stop at 4. Okay? Now this one's kind of weird looking. How low does this function go? Well, -4. How high does this function go? Well, -4. It stays at -4. If it stays at a number, it is just that number. Okay? All right. This one, so these are not arrows, remember? So they stop. So this function goes as low as -4. And this function goes as high as 2. Okay? No. All right, so we're still asking, is it a function? And what is the domain in the range? Okay? All right, so is it a function? Does it pass the vertical line test? Yep. So yes, this is a function. Okay. This one, does it pass the vertical line test? No, it does not. So this is not a function. Okay. So then we're going to do the domain. Okay. All right. So this one does not have arrows. So how far left to how far right it goes? Well, left, it stops at 2, and then so it starts at 2 and then it stops at 3. These are open dots, so it's going to be parentheses. Okay? Domain here. There's no arrows here, so no infinity. Okay? If you have no arrows, you don't have infinity. Okay? So how far left does this go? Well, the furthest left it goes is -2. Now, is there an open dot there? No, so it's a bracket, okay? But then it stops at 4, and both of those are open, so it's a parentheses, okay? Now, if one of those had been closed, it would have been a bracket, okay? Closed trumps open, okay? All right, so range. Range is next. Had a little brain stop there for a minute. All right, range is how low to how high. Well, this goes as low as 1, and it goes as high as 3. They're both open, so parentheses, okay? Range here, how low does it go? Well, it goes as low as -4, and it's open, so it's parentheses. This one goes as high as 3, which is parentheses because it's open. Okay? All right. Let's keep chugging along. 2 more slides. Okay? All right. So, is it a function? All right. Does it pass the vertical line test? Yes. Bam, bam, bam. Yes, it passes. Okay? All right. This one, does it pass? Now, I want to talk about this because, yes, it passes the vertical line test. But you see how there's an open on a close and open on a close? That is fine, okay? As long as one is open, as long as only one is closed, it is still a function. If this was closed, it would not be a function, okay? So when you have dots like this on top of each other, the summary is only one of them can be closed for it to be a function, okay? All right, so now we're going to do domain and range. There are no arrows, so we're not going to have infinity here, okay? So domain, how far left does it go? Well, the furthest left it goes is right here at -4, which is open, so it's a parentheses. How far right does it go? Right here, and that looks like about 2.5. Now it's closed, so we put a bracket, okay? This one. Now, also this one's good because there's no gaps. You see how there's no gaps? Okay, it picks up and keeps going. Even though it's on another line, it still picks up and keeps going. Now there's arrows down here. So it's going far left and far right, which is going to be -infinity to +infinity. Okay? Range, how low does this graph go? It goes as low as -2 at an open dot. And this one goes as high as 3. And it's a closed dot, so it's brackets. Okay? All right. This one, again, it's not skipping anything, and it's going far down, and it's going far up, which is going to be -infinity to +infinity. Okay? All right. So that is it for function notation with domain and range and converting to function notation. All right, guys? So let me know if you need anything else.